Good morning and welcome everyone. Thank you for taking time to attend this session. My name is Sumit Kumar. I'm a product manager in the Azure Data Group, and my area of focus is building machine learning technologies inside of data products and services. And today in this session, we're going to talk about machine learning services inside of SQL Server and how this technology, this feature of SQL Server, effectively transforms this into an end-to-end machine learning platform for developing enterprise-grade ML and AI applications. Just a quick show of hands. How many of you are using machine learning services or are services in production today? A few, of handful. How many of you have actually done something with it, as in built a prototype or have played with it a fair bit, but haven't put anything in production yet? About 10 or so. And so I'm assuming rest of you are either not very familiar or have just barely heard about this technology. So what I'm going to do is, it's an intermediate level session, so I'm going to cover material that will be hopefully helpful for everyone. OK, so before we get into the demos and showing how things actually work, I just want to understand sort of what I mean when I say in-database machine learning. Right? So everybody, whether it's a small company or a big enterprise, is building AI and ML applications today or trying to do that. And the current paradigm is that the data scientists or the machine learning experts get the data from whatever data sources they have, whether it's a database, text files, or data lake, and then they pull that data, they do the transformations on it, they do feature engineering on it, and then iterate through multiple versions of sort of multiple rounds of training, and then they build a model, and then that model gets embedded in the application. So instead of that model, that paradigm, how about if the models and sat right where the data was, instead of being pulled outside of the data store and being embedded in the application, the model sits right with the data, and it's an enterprise that asset that's available to every application. Right? So let's double click on this, sort of blow this up picture up. So typically, the databases get data from applications write data into the database, and of course they get data from other sources as well. And the data scientists and the ML experts, they pull data out in a separate sort of analytics server. Oftentimes this is just their laptop, right? And so that is where they do their data exploration, transformations, and machine learning model training. And once they have built their model, they then have to build a system to operationalize it or make it available to the applications. Oftentimes it's a separate sort of endpoint or a service or a logic embedded in an application. And then when the model needs to be sort of used for training or scoring new data, the new data then gets into this service or endpoint, and then ultimately the predictions go into the applications. So there are a lot of problems with this thing, right? In fact, this is not sort of totally hypothetical. Some of our customers have the systems like that, right? So what are the problems? Number one, moving data out of the SQL Server or wherever your database is, data store is, has challenges in terms of compliance, security, access control. And oftentimes, machine learning models require large volumes of data. And if you have to move large volumes of data, you have to build infrastructure around that. That is if you're allowed to. In the current day and age of GDPR, oftentimes you're just simply not allowed to move data out of secure boundaries. So let's say by whatever means you're able to do that, oftentimes you're forced to work with samples of data instead of being able to use the whole data sets. Now, for some machine learning algorithms and techniques, samples are just fine. But there are some other machine learning techniques where the larger the volume, the better the quality of the models are. Right? And so when the data scientists then build the model, putting it in production often means that they toss it over to their, the application developer team, and the models are written in Python or in, R, and they literally translate it into a different language, Java, C#, whatever. And there is a loss of fidelity in the translation. There is a latency in the overall process and all of that. So there is a lot of pain in the system. The overall iteration, the cycle takes months. And by the end, in the end, when the model is actually deployed in production, the data scientist doesn't even recognize that model. So instead of all this, doing all of this infrastructure and this movement of data and everything, what if the new paradigm is this, right? Databases get data as always. And everything, right, from data transformations to model training to even the models that are actually used in production for scoring new data, everything sits right in SQL Server. Okay? And the applications just get the predictions. So all the hassle of building that infrastructure, depending on somebody else to give you data, to do training, all of that is gone. Right? So that's the big value proposition. All right? Again, another show of hands. How many of you in the audience are sort of the data scientists or the machine learning experts or the people who predominantly code in R or Python? A handful. And how many of you are people who write applications, code in C#, Java, high-level languages? More than about half. And then how many of you write SQL code as the primary? Again, almost everybody. All right. So, so there is, in this technology, there is something for all of you. So we'll see how this helps the application developers first, right? So now for application developers, your goal is to make your application that you're building or your existing application smart by leveraging a model, machine learning model, that has been built by somebody. Now, you don't even have to think about models or be aware of what is happening inside them, to what is this coefficient thing that you would have had to in the past when you would have had to translate the models into your language. You can now just call a stored procedure and access and leverage that model without doing anything. So let me actually quickly show you a demo. All right, so imagine I am a nurse in the emergency room. So I'm looking through a queue of patients who have gone through the ER triage process, and I need to make a decision about what kind of room and staff to assign to this patient, so that number one, I can utilize the resources of the hospital properly, and I can ensure a good outcome for this patient. So this is a simple web app, and I just use this thing to admit the patients in the right room. But now, as soon as I hit the admit patient, immediately it came back with a forecast that this person is likely to stay in the hospital for about 2 days. Now, equipped with this information, I can make smarter decisions about resource allocation and staffing. Right? So how did this application do this? Let me quickly show you the code. This is a JavaScript app. It isn't really doing anything smart, particularly smart. All that it's doing is making a call to a stored procedure. That's where everything is happening. So let's take a look at what's happening in the stored procedure. It's running a model that has been trained from historical data from other patients' information, which has trained a model based on their history, based on their other factors. And then when they get admitted, it figures out the likelihood of how long are they going to stay. So this is the data that was used to train the model. But let me show you the actual stored procedure. For some reason, it's slow. OK. So what this stored procedure is doing is it's selecting a model which is stored as binary blob of data in a SQL table. And then it's getting the data for a particular patient ID. And then it is doing some transformations on that data, because in order for model to, before we train the model from the raw data, we made some transformations on it. Right? For example, calculating number of issues this person has had, and so on. Right? So we have to apply the same set of transforms to the data before scoring it. and you're doing some feature engineering as in generating new features from that. And then once you're done with all of that, you're just basically passing that model and the row of data in this line of code using native predict function that we have built in SQL Server. It's as simple as that. Okay? So you're not calling any R or Python code. You're not doing anything else. You're just writing T-SQL code as you always do. And in the application, you're just making a call to that. Right? So this was an example where you could just use a machine learning model without writing any R. In cases, you have to write that. And even for this model, for training, you had. I will show you the code that was used to train it in a bit. Now, even though the feature is called machine learning services, the way it is enabled is on languages in SQL Server. So that, of course, helps you build AI and ML applications, but it also helps you leverage Python and R for general purpose data processing. Hopefully, it'll connect back again. So while that is happening, let me connect there. All right, so even if you're not building any machine learning applications, you can. There are a lot of things, data-related things that SQL is very powerful at, aggregation-type things. But there are certain things that R and Python are uniquely powerful at. So you can combine the strengths of T-SQL and R and Python languages, and you can leverage that for general-purpose data processing. So let me show you a couple of examples, what it means to run R and Python languages inside of SQL Server, for example, first. All right. I had tested this connection a few times just before this. Okay, while this is coming up, I had a backup, and I'll show you that in a minute. Sorry about that. I have a fallback of screenshots. I can resort to that in a minute if that doesn't work. Okay. All right, if it doesn't come this time around, then I will. All right. Okay, moving along. So what do I mean when I say running Python or R code inside of T-SQL? In the extremely simple scenario, this is what it means. You have a regular looking T-SQL script. We have a special system stored procedure called sp execute external script, which takes language, in this case Python, and a script parameter. And this, between these two lines 4 and 6, this is where the Python code goes. And if I execute this, I get hello world, right? Right. So now, of course, this is a trivial example. You wouldn't do that. Let me show something else, right? One of the common, some of the things that Python and R languages are good at is the statistical operations, where you could achieve that in T-SQL, but it'll take you a lot of code writing. And because of the packages available in Python and R code, you can easily do some of the statistical operations. One of them is called principal component analysis. What this basically means is taking multiple, execute this, and what it's doing is it's combining all of those columns into a single column. I haven't even named it, but instead of using those 3, I can now use this for my machine learning model training. So I talked about scikit-learn. You didn't have to do anything to get this package here. When you install SQL Server Machine Learning Services, we install a number of packages from open source, both the Python and R. For Python, we install a subset of the popular Anaconda distribution. And for R, there is something called MRO that we build, so it comes with that. But we don't stop at that. If you need some additional package, TensorFlow or whatever you want, you can just very simply install that as well. I will show that how do you do package installation in SQL Server in a bit. All right, so hopefully you got a sense of how this thing looks like. Now, the actual training code for the model that was used for running this thing was also, so this is the actual training code. Again, it's a similar looking regular T-SQL script, but in here is the R code that was used to train the model. And I will show you end-to-end from the data scientist perspective how that goes. But this R code is embedded, and it does the training and the writes model back into a SQL Server table. All right. So now, that was a sense of sort of how a developer or a data engineer would leverage the integration of R and Python and the availability of model for their AI applications. What about data scientists, though, right? Because that is needed. They are needed to build the model, and that can be used for applications later on. So data scientists, again, a lot of their problems go away with this thing. They are not forced to work with samples. They can work with the whole data sets. And the best part is that they can stay in the environment that they like. They don't hang out in SSMS and SQL as much. They use SQL Server as the data source generally. So let me show you how this thing works, enables you to work from your favorite IDE, whether it's RStudio or Jupyter Notebooks, wherever data scientists hang out, but still leverage the full power of SQL Server Machine Learning Services. So on this machine, imagine this is my client machine, and I have on this machine something called a Python client for machine learning server, which is available on MSDN. So you can basically, it is the client version of the exact same component that make the machine learning services. So there is a R client as well as Python client. So this is what I have installed on this machine. So it creates its own Python environment. It creates the same set of packages that I need, as well as it also has the Microsoft's custom packages as well. So now my Jupyter Notebook is running. This is the Jupyter Notebook, which is favorite tool for data scientists, for those who are not familiar. So what I'm doing here is, the scenario here is like this. It's the support ticket classification. I get support department in Microsoft, and other companies get a bunch of support tickets, and you need to route them to the right department or team. So how do you classify it quickly based on the subject and the text of the tickets and route it to the right team? Now, we couldn't use the support data So we are using a public news group data, and the problem is similar, right? So there is a subject, there is a body text. You use that to classify into different categories, labels that have been created. So while still being in my favorite IDE of choice, I am just making a connection to SQL Server. Okay? In this case, the server happens to be localhost as well. And here I'm doing just basic exploration type thing. I'm just saying let's look at the data, what it looks like. Let me give give me top 5 rows. So here I study, I do my analysis, etc. So these are the kind of things that data scientists always do, exploration. Now, in this example, it's a little bit more interesting example. Here, I want to visualize, do analysis on data and create visualizations from it. For example, I want to see what is the spread of how many word counts are there in the subject, for example, right? And so that I can think of creating right kind of features and giving right weights to it. So here I will be using open source package called matplotlib. And I will run this package within SQL Server. So even though I'm getting the results here, everything is actually happening in the SQL Server. So let me just execute this thing and walk you through the line of code. This is a RevoScale Pi package, is one of the custom packages that Microsoft builds. In addition to providing you some of the ML algorithms, it provides concepts like a remote compute context and the data sources. So this is what enables you to understand that, yeah, this data is coming from SQL Server and treat it as in a certain way. And then I'm importing the matplotlib. This is one of the popular Python plotting libraries. And I'm giving it the connection string and getting the data using this query from SQL Server. Okay, and then I'm importing that into a pandas data frame. This is what is being now passed to the matplotlib library, pyplot module, and then I'm giving it the things that it's needed for drawing the plot appropriately. And then what I'm doing is, this is a function that is part of the RevoScale Pi library, which allows you to package an open source algorithm and ship it to SQL Server and make it execute there. So I'm saying this function that I defined here, ship it using rxexec, and here's the compute context, as in run it in SQL Server. And then when the result comes back into histogram variable, and I just want to display that image. So none of the data moved. Data stayed there. Compute happened in SQL Server. I just got the result back here interactively. So my life as a data scientist has improved significantly because of this now, right? So now, in this case, I'm doing some additional things. So that was to show how you can use matplotlib or any other open source package. So if it suits your needs, you can just use that. But there are other algorithms that we add in RevoScale Pi and RevoScale R and Microsoft ML packages that Microsoft creates, which allow you to do training in a scalable way on data sets that are larger than what your memory can hold, for example. So I will, in the next cells, I'll show you examples of those. Here, I'm using Microsoft ML package, which includes some of the algorithms and APIs for doing text analytics. So generating features from text data so that you can use it for machine learning models requires you to do certain transformations. So it comes with built-in transformations like featureized text. So what I'm doing here in this section, again, is defining a transform that will be used for training. Execute this quickly. And then it's just saying, hey, remove the stop words. This is the language. And then generate hashes for those features, right? So nothing. And then this is where I'm actually doing the training. So I'm training a logistic model, and I'm giving it the subject, the pre-processed hashes from the subject, and pre-processed hashes of the features from the subject of the text of the support ticket or the news group cases. And then I'm determining the label. This is what we call the formula, and then the training. We are using that for the training. And in here, we are passing the formula, and we are giving it other details that this algorithm requires. And then the model is created in this object, and then we are writing this model. Again, I'm staying within SQL, within my Jupyter notebook, and I'm writing this model into SQL Server in a table called, and I'm giving it the name called LR. So I didn't, again, have to leave my favorite environment. I didn't have to depend on anybody to operationalize my model. It just got put into SQL Server, and it's available for others to consume. Right, so in the next section, I'm doing the actual scoring based on using that model again. I can run this model that was operationalized in SQL Server, and I can run it again right from my ID. So I never have to leave, and yet I am able to achieve everything in database. Okay, so this is the model, and it scored. As you can see, some of the scores were right, some of the scores were sort of slightly off, as any ML model is supposed to do. Now, so once I'm done with this thing, I actually can put this into production. So I will show you how we have a utility that enables you to wrap these things into SQL Server, but let's look at what it looks like here. So the training code that I was showing you, the exact same code that I wrote in, if you can make it here. So exact same code that I was showing you in the IDE is written here, and it's embedded in a T-SQL script, and there are certain parameters that you have to use to bind it, to sort of plumb it appropriately. And sometimes this can be tedious, a little bit tedious and error prone. So we have created utility that I'll demo in a bit. OK, so now moving along. So hopefully this gave you a sense of sort of how, as a data scientist, I can do complete end-to-end thing, leveraging the power of SQL Server without moving data out. And one of the things that I didn't talk about is you can, is the last point about model version management. So as part of the practice, you often have to create multiple versions of models, and you do A/B testing to see which one is doing better on which data, et cetera. So effectively, you can build your own model management system by creating different rows of models and different versions of for different versions of model in a SQL Server table, and that's how you can manage and do A/B testing, et cetera. Right. So, so hopefully you got a sense of sort of not just how data scientists is benefited, but it enables the overall sort of better collaboration between different sort of personas that are involved in building an AI application, right? So your data scientist, we just saw the thing, is working in their IDE, exploring data from SQL Server without moving it, and then they're building models using R and Python language, embedding it in T-SQL scripts, and they're working with the SQL developer or DBAs to embed that in T-SQL stored procedure and operationalize it in SQL Server, and then the application developers just basically consuming that, right? So that overall sort of improves the efficiency and the better collaboration. OK, so in addition to sort of enabling you to run R and Python code and do all of this, we didn't just stop at that, right? So we have built a number of powerful sort of performance features that help you extract more, get more juice out of this, right? So because it is deeply integrated with the SQL query engine, you can do a lot of things like run things in parallel. So let's say there is a SQL query which is taking a long time. What you can do is you can chunk results of SQL query and pass it to the R and Python to do its thing in parallel while the SQL query is still executing, right? The other thing is a bunch of the algorithms that we include on top of the open source algorithms allow you to do scalable training and scoring, for example, right? So you can literally scale to infinite amounts of data, as in you don't have to be dependent on the amount of memory available because you're chunking data from disk and you're doing training on that, and then you're aggregating. And then you can combine all of this with the SQL Server innovations like the in-memory and column store technology and get even more additional benefit. So these are the things that you gain over doing ML training outside of SQL Server. And then we are building additional sort of features, right? So native scoring that I demoed in the very beginning, the predict function allows you to do scoring of certain models that have been built using the RevoScale algorithms in a matter of milliseconds. If I have time, and then I'll show you the actual execution of that. It takes tens of milliseconds to run a predictive model, which is stupendously fast. And the way it does it, it has taken the scoring part of the Revo engine, and it has put integrated natively into the SQL engine, so it doesn't have to depend on an external runtime. So, but this being part of SQL Server, the DBAs are concerned about running, allowing an external runtime to run inside of SQL Server. So we have, of course, made sure that their concerns are addressed. We have taken care of security and resource governance very well. So I will not go into the details of all of this, but the main thing is that the R and Python code runs in a separate process. So if something goes wrong in that, it will not bring down your SQL Server process. And even if you install it, you need to have explicit permissions to run external scripts, R and Python scripts, and different users have to have the explicit permissions, etc. And when the R and Python processes run in DB, they run under very low privileges. And they run in a very isolated way. One of the new things that we have done here is, in this release, the CTP2 of SQL Server 2019 that was announced yesterday, is we have changed. The model was that we used to create 20 or local users by default, and R and Python processes used to run in their context. Now there were some issues with that. Some customers had problems because their policy did not allow them to create local users on SQL Server. So now we have changed that to something called app container, and this is exclusive to Windows. So now each of the R and Python processes run under a different app container SID or context, and so they cannot talk to each other. They cannot communicate outside on the network, etc., for example. And because of the built-in resource governance, you can precisely control how much memory is available to R and Python process. You can even define which CPU to execute your R or Python code on, and so on, right? So there are none of these is like, except the app container part. These are all things that have been there in the last couple of releases, and it's very well documented on our MSDN document, so I won't talk more about it. But what else is new in SQL Server 2019 CTP2.0 that we announced yesterday? Did any one of you go to Rohan Kumar's session? Okay, a few of you. So for ML services, we announced that we now support ML services on SQL Server on Linux as well. Starting yesterday, you can now actually download it, and you can run it on SQL Server on Linux as well. And it's supported on all flavors of Linux wherever SQL Server works, whether it's Ubuntu, Red Hat, or SUSE. What you do is you basically install SQL Server, and then you add a few packages that you need for ML services. And because of the ML services support on SQL Server on Linux, you can also leverage the machine learning on the SQL Server big data clusters that was also announced. Anybody heard that announcement? All right. So now you can do, on the master instance, you can do ML machine learning as well. The other thing that we have done new is enable you to, one of the most powerful thing why R and Python languages are popular is because of the ecosystem of packages. You think of a problem, chances are somebody in the community has already created a package. So how do you install that package on SQL Server easily for your exploration first, and for actually putting it in production. So in the past, you had to be an admin on the box, and you could just then go and install like you would on your local desktop or laptop. But we have since been creating APIs and utilities for you to use. So in 2017, we added the library management APIs, where you can use SQL create external library commands to create and install libraries or packages on SQL Server. But yesterday, we released a utility on GitHub publicly called SQL ML Utils. This allows you to write R and Python code, again from your IDE, and install packages very easily on SQL Server. Let me show you a demo of that. So again, this is a client machine where I have R client installed. I've shown some examples with Python. Let me show some with R. And this is my popular IDE, RStudio. So what my IDE of choice, RStudio. And so I've installed SQL ML Utils package from that GitHub repo here. So I want to see what packages are installed in SQL Server, are available in SQL Server. So I can run it right from here. And using this API call SQL install.packages, I can figure out what is available on the SQL Server for me to use. And it went ahead and it showed these are the packages. And I'm, for example, interested in a package called glue. I see that it is not available here, right? And it went and it looked at the packages and the location in SQL Server, and all these packages are in the scope of system. So now, let's say I want to now install this package. So I'm using another API called SQL install.packages, and I'm giving it the connection string to go to talk to that SQL Server in this airline test database. And I'm giving it the packages that I want to install, which I've defined here to glue. And I'm giving it the scope that I want it to be available publicly to everyone. By the way, these scopes have to be defined by the DBA to get you access to install packages. So it's now, first of all, verifying permission, whether I have the permission to install the package on SQL Server. And then it's also resolving the dependencies. Oftentimes, these packages depend on some other packages. So there's no point in just installing that package on the server without dependencies. Then it will not work. So it did all of that, and then it installed, right? So now let me check again whether this package is installed or not. So it's now going and looking for the package, and then yes, of course, this glue package got installed. It got installed in a particular path, and that I'll show you in a minute. So it came here inside the external libraries in SQL Server, and it's giving the database ID and the user ID, and under that scope, it installed all the dependencies that it needed. Okay. So now, let me open this thing. So if I now run this thing here, it'll work just fine, right? So it says, hey, library glue is available in SQL Server. So not only that, let's say I experimented with the package and I don't really need it, and I don't want to pollute the server. I can easily go and uninstall the library as well. Oh, so now let me I can see, first of all, that run the thing there, do whatever I want to, execute some code. And one of the other things that this utility provides is the ability to execute a function in SQL Server, right? So it's called execute function in SQL. right from here, it's going and executing there, right? The function that I just defined. So it again takes a connection string. It takes a function that I have defined here. This function is basically using this glue package, which it's a nifty package that allows you to append text to objects, right? So here it's taking a numeric object and so on, and then it's combining some certain text to it. So let's run that package. So it went ahead and ran there. So my name is Fred, and blah, blah, blah. It did all these calculations that it was supposed to do. And then when I'm done with it, let's say I don't want it. So what I'll do is I can even remove .packages, execute remove .packages from here, and it will remove the packages from the package from the server. So I executed it here, and it's going and deleting that from the SQL Server. So successfully removed the package. Now if I come here and if I execute this, so it's going to give me an error saying the package called glue is not available. And what happens to that library location, you will see that this is removed from here as well. So the glue package isn't here, right? So that makes it convenient for you to install, experiment with different packages, and make progress. The other thing that this, I talked about the creation when you have the R code or Python code and you want to write the T-SQL stored procedure to operationalize it, you have to do a certain amount of plumbing so that there is a data being passed from SQL queries into R runtime and Python runtime and back. So that can be a little bit tedious, and sometimes it's easy to make errors. So again, this SQL ML utils makes it easy for you to create a wrapper T-SQL stored procedure. So let me show that. So here, using that same utils library, I want to operationalize this particular function called sppredict, where I am training a model, RxLin model, and I am predicting the model as well using that model and input data frame. This is the data that I get from SQL Server, a SQL query. So I'm defining the connection parameters here, and the name of the stored procedure that I want to create is called prediction. And then I will be able to create a stored procedure in SQL Server using this function called create_proc from function, and it takes all the parameters that I've defined before. Okay, and then this is where I can even execute that stored procedure that just got created in SQL Server right from my ID, and I can give it a certain, whatever query that I need to pass. And when I'm done with it, I can even drop the stored procedure because for whatever reason, if I didn't need that. So let me execute that one at a time. So before that, let me show you that there is no stored procedure called, right now, there is no stored procedure here called prediction, right? So there's nothing here. So now let's create this. Hopefully we will see, okay. So now it created a stored procedure. And then let's take a look at the code. So what you see here is it created all that plumbing for you. It has figured out that it needs this input data one parameter that goes in the R code as input data frame, right? So it took care of all of that for you, right? And now I want to just execute that thing from here and see the predictions. So it went ahead, it executed in the SQL, it brought the results back, and it gave me the thing here. So if I want to run this thing in, now I can actually execute this thing in SQL as well. I'll just give a, right? So this is a stored procedure. It was very easy for me to put it in production. Now an application can actually call it and get the predictions like I showed in the other one. All right. So hopefully that gives you a sense of sort of how this utility package helps you in a number of different scenarios. So what else have we done that is new in this release, right? So in the past, machine learning services did not work on failover clusters. So we've added that support now. So that was one of the big customer asked for us for a couple of releases. The other thing that we have done is support for partition data. So you can run the algorithms in parallel and sort of give different partitions of data automatically train multiple different models. You don't have to write different training algorithms for it. And so the way we are doing it is in the SP execute external script system stored procedure, we have provided some additional parameters that enable you to do that. In our documentation, we have a very good end-to-end example that you can try. I did not have time to show that here. Now, this is in addition to the RX exec by APIs that we've had since the last release, where you can do the same thing using R and Python languages. Now, we started with ML services in SQL Server 2016. At that time, it was called SQL Server R services, where we had support just for R. In 2017, we added support for Python. We rebranded it to SQL Server Machine Learning Services. And in this release now, I don't know if you guys caught this in the announcements, we have now added yet another language. We now have support for Java. Using the same extensibility mechanism that we have built into it. So just to show that, let me invite my colleague Nelly. Nelly.
Hello, guys, can you hear me? The mic is.
No, it doesn't look like. Hello. Can you turn the mic on?
Hello? OK, guys. All right. Yeah, so I'm going to steal a few minutes of your time to show you a little bit about how this Java extension that we've added works for SQL Server 2019. So you will be able to test this if you want on your own. And I can write up a link that you can go to in the end. But I just wanted to show it to you. So there are documentations on our docs online where you can actually go through an end-to-end sort of sample. But before we start, I would like to know, because I heard like Sumit was asking, are there any Java developers in here? People who do Java. OK, there are some people. Great. So what I wanted to show you is that I wanted to show you this Java language extension, but in the context of machine learning. So, and it's kind of, you can see more about this particular demo if you come to the deep dive session that we have tomorrow on SQL Server and big data, because then we're actually going to show this end to end. But I know it might sound confusing because I'm like mixing Java, machine learning, and big data, but we can go through this. So, what I wanted to show you today was how you can actually take advantage of this Java language extension in the context of machine learning. Now, how many of you have heard of the mLeap format? All right, so let me explain that. So let's say that if you're doing scikit-learn today, or Spark machine learning, or using TensorFlow, so what you can do is that you can use this open source model format. I would say it's kind of a way where you train something in Spark ML, TensorFlow, or scikit-learn, somewhere else, and then you bundle this as an mLeap bundle. So this model you can now export from that environment. And then what I'm going to show you is that how you can actually put that in SQL Server and score or predict on that model from SQL Server now with the Java extension. Because what you need to do this scoring when you're using mLeap is basically a JVM. That's the only thing you need. And mLeap is, you could say it's a common serialization format of a model. And it's open source. and the core engine of it is in Scala, actually. But since Scala and Java are compatible, that's why you can use it. So I hope it doesn't sound super weird, but it's actually very exciting because in the context of having SQL Server now including HDFS and Spark, I don't know if you heard that announcement, but this is the SQL Server big data that we're talking about. It basically means that SQL Server 2019 includes, you should see it that way, kind of includes, you'll have access to your HDFS storage, you'll have access to the Spark engine, so you now have the Spark engine and SQL engine, you know, it's part of the same SQL Server release. And that means that you could actually train using your Spark engine, export into an mLeap bundle, and then score that on the SQL Server master instance, if you're talking big data. So that's what you would be able to see tomorrow if you go to the deep dive session. But what I'm going to show today is that in the demo, I'm going to show the actual training has happened on Azure Databricks, because you know, we trained it in Spark in Azure Databricks and just exported the bundle, put it on a SQL Server instance, you know, on a local machine, and then you can actually use the Java extension to score. Now, a little bit more about the Java extension. So as Sumit mentioned briefly, the framework that this is sitting on is the same extensibility framework that R and Python are executing on. There's one difference, and the difference is that in the Java case, you're bringing your own Java runtime. So if you already have a Java runtime installed, you can point to that basically and say, this is the JVM I want to use. And the versions that we support today, on Windows, on the CTP2, we support Java 10, but you can run 8.2. I've tested it, but it's just that we haven't run it in our labs yet, so we can't really say that we support it, but it's definitely coming. So Java 8 is coming on Windows. On Linux, it's currently Java 1.8, the GRE 1.8 that we support. So the framework of it is still the same. I'm not going to go into the details of the architecture, but if you know the machine learning services architecture, it's built on the same architecture. It's secure. It's isolating the Java process, and all of that, it still, you know, applies to this. And the language that you would put in the SB execute external script would basically be Java as a language. Now, of course, there are some rules of what you actually need to implement in your Java class to be able to do this communication. And you can read all of that on the docs, and I'll share the link in the end. You can go and read about that. But we're always trying to improve now the experience. So if you're a Java developer and you want to give me feedback, please come up to me and talk to me. I'm happy to get your feedback and opinions on this. Now, let's take a look at how this actually looks. So let's see if my remote connection works, Sumit. I know. See if I'm. All right. So just quickly, here's my, I'm using IntelliJ. I have my Java class here. There are some certain things that you need to implement in your Java class. And this is actually, you need to basically be able to tell SQL Server from your Java class, what am I going to send you? And what do I want to receive, and where do I want to store it? So there's this kind of handshake that needs to happen. So for that, we've documented this on the docs. You would need to implement, certain variables, like declare certain variables, instantiate certain variables in your class. And then, there are these type of, I guess, rules or requirements for the implementation. And we're working on making this even easier in upcoming CTPs, and that's why I want your feedback, because you'll have the chance to give me some, some feedback that can actually be incorporated into the product. Now, to keep this short, we don't have that much time. This particular row. So when you're using mLeap, you need to first put your data in a specific mLeap data frame. And then you need to push that type of a data frame into like whatever Scala method. Now we have wrappers around this, but underneath it's a Scala engine. So we're pushing this now this mLeap model that we exported into a zip file. We're pushing this in here into the scorer run method. So, but I wanted to run this so you can see it from SQL Server. So the scenario here is that I have some data on age and hours worked per week, and I want to be able to predict if the income level is going to be above or below 50,000 per year, $2,000 US per year. So basically, if I would get a person with their age and hours worked per year, I would be able to predict with this model if they would make more or less. So here you see the Java language. Are you guys seeing this? Or should I make it bigger? Even bigger, or is it good? Okay. All right, so the Java language. So from the script now, Java, you need to pre-compile it, right? Because it's not it's not compiling, it's not a scripted language like R or Python. So you need to pre-compile, put your class files somewhere where SQL Server can find them and has permissions to, and all of this is documented. And then you are calling, now we have a package that we're calling SQL. So I happen to have a package, so I need to put that there. I have a class that's mleap model, and now I have a method that's called score. And now this is uppercase, but usually, you use lowercase. And then I'm pushing an input query, just like Smith was showing, to R and Python. I'm saying that push this query, whatever results I get, into the Java runtime. And then I have my class path, which is important because I need to tell it, where's my class path? Where are all my classes? And you can have multiple class paths here. Or you can even set system environment variables to declare your class path. You also do that for your Java home, by the way. You need to declare that on Windows, definitely. So this runs both on Windows and Linux. And then I'm pointing, to my jar file where I have everything. Now in the mleap case, I need the mleap runtime as well. So I've bundled everything, like the runtime itself to score, and everything in a fat jar that I'm pointing to here. So let's execute this one and see if we can get any predictions back for the data that we have. So I pushed some data here into a table. So you can see it's like a 17-year-old working 20 hours per week. And you can see, that data there. So let's run this. So it's now calling, when it's doing this, it's calling the JVM, running my classes with the data that I'm pushing to it, and then sending me the results back as a result set. So that's basically, you can see here that, and I could also add an ID here. This was just a very simple sample, but basically to see that, okay, the probability with 96%, this person is not making more than 50,000 and so forth. So that's what the model is returning, but just as an example to show you that you can actually communicate with the Java runtime this way. That's, thanks.
Is this on? Hello? Excuse me? In the back?
Oh, okay.
So thank you, Nelly. So you saw the power of the extensibility framework that we have built into SQL Server is enabling us to add yet another language. So we don't know what the other future languages will, maybe Scala in the future, but the point is that we have built this infrastructure that enables powerful scenarios. All right, so where are we going with in-database machine learning in general? So we just announced the preview of SQL Server 2019. We will continue to work on it and refine things in ML services on Linux, as well as potentially building other ML type scenarios that are put into the SQL Server big data clusters. So that will happen as the SQL Server 2019 approaches the GA. The other thing that we have been working on for a while is bringing this machine learning services into Azure SQL database. I know we shared that we had a limited functionality preview some time back, but then because of some chipset issues that you might be aware, we had to pull it back, and we are very close to announcing the preview very soon. So if you're interested in being a sort of early adopter for that, please let us know. I will share the contact information in the end. And the other thing that we are continuing to do is we already have a few pre-trained models, things like extracting sentiment from English language text, extracting features from images. So those are the models that take a considerable amount of expertise and resources to build, and often they are just very easily leverageable in a different domain. So you don't have to reinvent the wheel, we pre-build those models and we package that with or provide that for you. So we will continue to build some of those other ones as well. And then with this SQL ML utils package in the open source world, we will continue to add a sort of stream of utilities that you can leverage for using machine learning services. And it's going to be open source, so we encourage and invite contribution there as well. And then we have the roadmap to sort of bring machine learning services on all the Azure data products wherever it's relevant. So we don't have a defined sort of ETA for any of these, but the next after Azure SQL Database would be SQL Database MI, and then SQL Data Warehouse, and so on. If you have specific asks, we would love to hear from you about your scenarios. Use user voice, use direct communication, whatever works for you. So that's where we are headed. And then for SQL Server vNext, or no longer vNext, SQL Server 2019, if you want to test the new features, we invite you to sign up for the EAP program, or the early adopter program. You can do that, use that channel for Azure SQL Database as well. And SQL Server 2019 CDP 2.0 is available. Please explore, provide us feedback. That's my email address. We can provide other email addresses as well. So that's about it. We are open to questions now. And we will be at the booth in the data and AI section. We also have our senior colleague here, UC. So anybody has questions, we can take those now. And please provide feedback. Thank you.